So these double angle identities, we're gonna kind of prove from using the sum and difference identities from last class. Bless you. Okay, so we're gonna start out with sine and cosine, sine, and then we'll do tangent, and then we'll do cosine. So it says sine of x plus x. Well, we talked last class about sine of a plus b. So if I use sine of a plus b's formula, that's using formula number 18 on my gold sheet, right? So if I plug in x for a and x for b, we end up getting sine of x, cosine of x, plus cosine of x, sine of x. Okay. Now, sine of x, cosine of x, cosine of x, sine of x, those are like the same thing, right? That's like if it was xy plus yx, those are the same thing. So if I combine those, if I add those together, what would I end up with? 2 sine of x, cosine of x, or 2 cosine of x, sine of x, right? And then if you look on the back side, that is actually your identity number 24, okay? Because this could also be written as sine of 2 times x, right? Hence where the double angle phrase comes from for double angle identities. Again, all you need to know is how to use this formula, or maybe how to use it backwards, and we'll talk about how to do that today in class. I'm going to skip cosine of x plus x for a second and go to tangent of x plus x. If I do tangent of x plus x, this is a plus b. We're going to use number 22 on your gold sheet. And if I plug in those x's and into my formula, I get tangent of x plus tangent of x divided by 1 minus tangent of x times tangent of x. Okay, now if I simplify that using some algebra, what's tangent of x plus tangent of x give me? 2 tangent of x. And then in the denominator, 1 minus, let's see, tangent of x times tangent of x is going to be tangent squared of x. And if you just look at the back, number 26, this is your double angle identity for tangent of x plus x, because that's the same thing as tangent of 2 times x.
So what's your answer?
All right, and then the slightly trickier one, only because there's actually not just one formula for this, but if you look on the back, number 25 has 3 formulas for the double angle of cosine. So we're going to find all 3 of those using some other stuff that we have on the front of our sheet. So I'm going to start out with my formula from number 20. So number 20 is your sum formula for cosine. And if I plug in my a and my b as my x's there, I get cosine of x times cosine of x, minus sine of x, sine of x. Now, if I square both of those things or times both of those things, it's the same as squaring them. So I could rewrite this as cosine squared of x minus sine squared of x. And if you look at your back sheet, that is, in fact, number 25. That is one of my formulas. That is equal to cosine of 2 times an angle. Okay, or 2x in there is equal to cosine squared minus sine squared. Okay, so if you look at the back on number 25, the second formula in the middle is 2 cosine squared a minus 1. So they somehow got rid of the sine squared. Is there something that I could replace sine squared with to be in terms of cosine?
Minus cosine squared.
Say that one more time.
1 minus cosine squared of x.
Yeah. So I could rewrite this as cosine squared of x minus 1 minus cosine squared of x. That's using your identity number 9, right? Replacing sine squared of x with 1 minus cosine squared. And then if I just do a little bit of algebra here, this becomes cosine squared of x minus 1 plus cosine squared of x. And can I do some simplifying here? I sure can. Cosine squared of x plus cosine squared of x gives me 2 cosine squared of x, and then minus 1. Which, if you look on the back, that is your number 25. I'm going to call it B. That's like the middle piece there. Okay, that again is also equal to this cosine of 2 times x formula. And then the last one that I want to find is that third one that's there. So instead of replacing sine of x, I could replace cosine of x. What is cosine of x equal from the front side? Cosine squared, I should say. 1 minus sine. So I'm going to replace that. That's from number 9. Cosine squared is the same as 1 minus sine squared. And then I've still got that minus sine squared piece, right? So if I combine those together, I get 1 minus 2 sine squared of x. And then that is your formula number 25C. So that is where all 3 of those formulas came from, just using the different identities to simplify it. Okay, this is a little bit flashback from a few units ago, but it's also using double angles as well. So it's kind of putting 2 pieces together. So if you guys remember from last 2 units ago, I think it was, this cosine of theta is equal to a positive number, and sine of theta is less than 0. Okay, so I need to draw a little coordinate plane here, and I'm going to label my quadrants with the phrase, remember, all students take calculus. Okay, so these letters tell me where the sine and cosine and tangent functions and their reciprocals are positive or negative, right? So if I'm looking at a cosine value that is going to be positive, what 2 quadrants is cosine positive in? 1 and 4. So it's positive in these 2. Okay. Where is sine going to be less than 0? T and C, yeah. It's positive where it has S and A. So down in the bottom 2 quadrants. Okay. Hence, the overlapping piece is now where we're going to draw our triangle. Okay, so in the 3rd quadrant there, it says that cosine of theta is 3/5. So if I draw my right triangle here, remember when I draw my right triangle, I always draw the triangle to what? The x or the y-axis? The x-axis. So this is a right angle. We're going to call that theta right there. And now I'm going to label cosine of theta is equal to 3/5. So from here, my adjacent side is 3. My hypotenuse is 5. So Pythagorean theorem or your Pythagorean triples, what is that other side length going to be? 4. Okay, and specifically since it's going down there, this distance is going to be negative. Okay. All right. So now what we're going to do is we're going to, with this triangle, we're going to find sine of our double angle, cosine of our double angle, and tangent of our double angle using our formulas. Okay. So starting with sine of 2 theta, we're going to use number 24. So that's going to be 2 times sine of theta times cosine of theta. Okay, so from that angle, we are going to plug in the information that we know. So sine of theta from this angle, sine is opposite over hypotenuse. So sine would be negative 4/5. We okay with that? And cosine they already gave us. Cosine is 3/5. And now we just got a little bit of an algebra problem. So I got to multiply across the top and the bottom. When I multiply across the top, 2, negative 4, and 3 is going to give me negative 24. And then what am I going to get in the denominator? 25. Okay, so that is sine of my double angle using my formula. Now we're going to do the same thing, but with cosine. So cosine of 2 theta. Obviously, we've got 3 different formulas we can choose from. So I could choose to do the first one, and you guys could do the second one, and my third class could do the third one, and they're all going to be the same thing, okay? Just for time, I'm just going to choose one of them. I'm just going to do the first one, okay? So this is going to be cosine squared of theta minus sine squared of theta. That's my formula, but I could use either of the others. And then from our not from our gold sheet, but from our triangle we just drew, cosine of theta is equal to cosine is 3/5. So cosine, I would have 3/5 squared, and then sine squared, that is negative 4/5 squared. Okay, from here when I'm simplifying, make sure you square both the numerator and the denominator. So this is going to become 9/25. And then what's my second fraction squared going to be? 16/25. Okay, subtract those and I get negative 7/25. Okay, last one up there is tangent of 2 theta. So if I did tangent of 2 theta, again, I can use my formula. Tangent of 2 theta is equal to, 2 tangent of, I'm going to write this down, 2 tangent of theta over 1 minus tangent squared of theta. But then I also want you to realize, and I'm going to show both ways, I could also set this equal to my ratio of tangent, which is sine of 2 theta over cosine of 2 theta, right? As long as you have that same thing in parentheses there, it's going to evaluate to be tangent of that same thing, okay? So I'm gonna do the pink piece first here. So I'm gonna plug in what is tangent of theta. If I go back to my picture here, tangent of theta would equal what? Negative 4/3. So I'm going to plug that into my formula here. So I've got 2 minus negative 4/3. Wait, was that right? No, it's 2 times. Sorry. My bad. 2 times. And then all divided by 1 minus my tangent of theta, which is negative 4/3. And I'm squaring that. Okay, so I can go ahead and multiply across on the top. This would give me negative 8/3, all divided by 1 minus, square both things, that gives me 16/9. Got fractions and fractions. Let's clean this up a little bit. In my denominator, if I want to make that a common fraction there, make that times 9 times 9, right? So now I have negative 8/3 divided by, what's 9 minus 16? Negative 7. So negative 7/9. Keep, change, flip. So this becomes negative 8/3 times a negative 9/7. And that would become a plus. And if I simplify my 3 with my 9, I end up with 24/7. But honestly, if this was me doing the problem, I was already given what sine of 2 theta is and cosine of 2 theta is, so I would just plug those values in. So I'm going to show you that method as well, because my cosine is this negative 7/25, and my sine is negative 24/25. So if I evaluated this and plugged in those two things, your sine of 2 theta is, what did I say, negative 24/25. And then I'm dividing my cosine, which is negative 7/25. And if I keep, change, flip that, those 25s go away and I'm left with 24/7, right? So either way you do it, whether you use the double angle formula for tangent specifically, or just do a ratio of sine over cosine, you'll get the same answer regardless. Okay? Does that make sense? Cool. All right. Example 2 is very similar to example 1 there. So I'm going to let you guys go ahead and try this out. First, draw a picture of what quadrant you're going to draw your triangle in. And then just be careful because this negative does not have to be there. That negative could be written like 4 over negative 3, or it's written as negative 4/3, right? Just one of those numbers is going to be negative in your picture when you're drawing your triangle. Okay, so take a minute, draw your coordinate plane, figure out what triangle you're going to draw and where, and then see if you can't evaluate cosine of 2 theta. Negative 7 over 25, that is our answer. Make sure you're careful with drawing your triangle in the correct quadrant. And if you need help with that, make sure you come see me, okay? All right, again, you can also use other formulas for this. You don't have to use the cosine squared minus sine squared. You could have used the 2 cosine squared minus 1 or 1 minus 2 cosine, or sorry, 2 sine squared, and would have been the same answer, okay? All right, moving on. Next thing is we are going to go backwards, okay? So we're going to look at the right-hand side of the equation, and then we're going to make it into the left-hand side of the equation, basically simplifying it, writing it as one single trig identity, specifically the double angle identity, okay? So if I look at number 1 here, I've got 4 sine of something times cosine of something. So let's just call these both our A values, and then let's go look at our 24, 25, and 26. Which one does this look like? If it's sine of A times cosine of A on the right-hand side of my equations. Looks like number 24, right? But number 24, it says sine of 2A is equal to 2 sine of A times cosine of A. Well, I agree that we have the sine of A cosine of A, right? But how do I make this a 2? What do I need to do with this 4? I can't divide because I don't have an equation. But could I just like rewrite it like this? Yeah. So if I rewrote it as 2 times, well now this 2 makes this full equation accurate. So now I have all of this. We just need to remember to bring a 2 out in front. So I'm taking 2 and I'm timesing it by 2 sine of alpha cosine of alpha. Okay. So we're going to have 2 times, and we're going to write this instead of 2 separate things. We're going to condense it and write it just as 1, where my A value is that 67.5. So this is times sine of 2 times 67.5. Okay, and 2 times 67.5, that's going to give me sine of 135. And I have a 2 in front that I'm multiplying it by. Well, what is 135? Sine of 135 from a unit circle? Root 2 over 2. So I'm going to have 2. Yeah, it's positive. Yep, so I'm going to have 2 times the square root of 2 over 2. And that's just going to simplify and give me the square root of 2. Okay, so let me go back and just re-explain that whole situation really quick. I saw that I had sine and cosine, and that was the only thing I had. So I know that it has to be my double identity number 24. However, it normally has just a 2 in front of it, but this one has a 4. So instead of having a 2, I'm going to rewrite it to be 2 times 2. So now this whole thing is equal to this right-hand side. So I can condense it. Instead of writing this right-hand side down, I can write just sine of 2 times my alpha, or my A. And then I've got that 2 from the beginning down in front that I'm bringing down for my answer. So I end up with square root of 2 for this one. Okay. If I look at the next one here, the next one I've got 6 sine of 22.5 cosine of 22.5. So again, still using that formula, number 22, I could rewrite 6 to have a 2 in it to be 2 times what? 2 times 3. Now I always want you to write the 2 with the sine and cosine piece. And then your 3 is going to be the thing on the outside, because that is not part of my identity number 24. But the rest of this stuff this whole thing looks exactly identical to number 24, where this 22.5 is my a value, right? So I can just replace 22.5 in for a and condense my equation. So I'm going to have 3 times sine of 2 times 22.2. And if I simplify 2 times 22.5, I get sine of 45. And what's sine of 45 going to give me?
Square root of 2 over 2.
Square root of 2 over 2. So this would then equal 3 square root of 2 over 2. All right, same thing for number 4, except for we've got some variables here for the first one. I've got cosine squared of 7x minus sine squared of 7x. If I look at my double angle identities, which one does this look like?
25.
Number 25. Okay, so my formula is cosine squared of a. So this 7x is my a value, right? So this is now then going to be equal to cosine of 2 times my a value, which is 7x. So this is just cosine of 14x. I can condense it because that's what it is equal to. They're the same thing. What does letter B look like? Which formula? 24, 25, or 26? 25. And the third one, right? So this is like 25C, I'm going to call it, where I've got cosine of 2a is equal to 1 minus 2 times sine squared of a. That's my formula. Okay, so this thing right here looks exactly like the right-hand side, right? Where my a value is going to equal 15. So I'm going to plug in 15 for my a and condense this into cosine of 2 times 15, which is actually equal to cosine of 30. And don't we know what cosine of 30 is? Yeah, cosine of 30 is the square root of 3 over 2, right? So this thing right here is actually just equal to the square root of 3 over 2. Fun fact. Okay, these last two are a little crazy because we're going to be verifying and rewriting using these identities from your sheet. Okay, so number 5 says to verify that the given equation is an identity. So this 1 plus cosine of 2x, if you look at the backside, 1 plus cosine of 2x, is that like an actual identity on here? Or is it maybe a part of an identity somewhere? Do you guys see it on the backside for 24 through 26? Doesn't it look kind of close to number 25 a little bit? It's got like those values, right? If I look at cosine of 25, that's not cosine of 25, but number 25, and I rewrote my formula, cosine of 2a is equal to 2 cosine squared a minus 1. If I just added this 1 over here and just kind of rearrange that identity, do you guys see now how I have a 1 plus cosine of 2x? Yes? Okay, so that's going to come into play. That's not like actually done. We're not showing that side there. But I'm going to show that the left-hand side of my equation here is going to equal this right-hand side, which is actually equal to what? This blue piece, right, that I have highlighted there from the equation is actually equal to this 2 cosine squared of a. So that's actually what we're going to get as an answer on the left-hand side to be able to show that it's equal to that, okay? So if I were to rewrite the left-hand side in terms of sine and cosine for cotangent, what would I write it as? Cotangent is cosine over sine. There we go. Cosine of x over sine of x. Okay. And then let's rewrite sine of 2x with my formula, number 24. Okay, so my formula for sine of 2x is 2 sine of x cosine of x. Okay, and the nice thing is here, what's going to cancel? Sine of x, sine of x. So now I'm left with 2 cosine squared of x, which is equal to this 1 plus cosine of 2a. From that double angle identity. Anytime you see a 2 inside your parentheses, you're going to somehow have to use a double angle identity in order to verify it. Okay? But that is enough. As long as you show this stuff over here as well, this is, in fact, proven that they are equal to each other. All right, so now we're going to write sine of 3x all in terms of sine of x, okay? Remember, the only formula that we talked about today is double angle, so this is like triple angle. So if I could rewrite this as an addition of two things, how could I rewrite the sine of 3x into? Like,
sine of x plus sine of 2x?
Yeah. Well, but it would just be x plus 2x in parentheses, okay? So I would write this as sine of 2x plus x, okay? Well, we're going to use our formula from last class with the sum of sine, so that's going to be number 18. And I'm going to rewrite this into sine of, this is going to be my a value, this will be my b value. So sine of 2x times cosine of x plus cosine of 2x times sine of x. Okay, so I'm not quite in terms of just sine of x yet, right? So I need to get rid of this cosine of x and this cosine of x. So let's go ahead and let's get rid of cosine of 2x because I have a formula for cosine of 2x, right? This cosine of 2x, if I want this to be in terms of sine of x, which formula from number 25 am I going to use? The first, second, or third one? The third one. So I'm going to use number 25C. And my new equation is going to be sine of 2x cosine of x plus, this is 1 minus 2 times sine squared of, x. Okay, I've still got a cosine of x there. I don't have anything that just equals cosine of x in terms of sine, right? So instead, what we're going to do is we're going to rewrite, because I have something about my sine of 2x, right? I could simplify sine of 2x. We know sine of 2x using number 24, that's equal to 2 sine of x cosine of x times another cosine of x. And then I'm going to go ahead and distribute this sine of x to both terms here. And this is going to become plus sine of x, and then minus 2 sine cubed of x. Okay, so I use that number 24 to rewrite sine of 2x into 2 sine of x times cosine of x. Which, can I simplify this piece? How could I rewrite that first term?
2 sine of x cosine squared.
Yeah. And that's still quite a bummer because I have a cosine squared of x. But what do I know about cosine squared of x? What does cosine squared of x equal? 1 minus sine of x. So using number 9, I can go ahead and replace this cosine squared with 1 minus sine squared. Wild. And now everything is in terms of sine. Now let's just simplify it. Okay? So I gotta distribute this. 2 sine of x. 2 sine of x times negative sine squared. That's going to be negative 2 sine cubed of x. And then I've got my plus sine of x minus 2 sine cubed of x. And one last step, a little combine like terms here. How many sine of x's do I have? 3. And then how many sine cubes do I have? Negative, how many? Negative 4. Oops. What a wild time that was. Crazy stuff.